Okay, so I know you've already done Pythagorean theorem, but what we're going to work on today is not using the calculator as much. So in other words, I don't want decimal answers, I want radical answers. And more than that, I want simplified radical answers. So let's start with a basic example. Remember, the Pythagorean theorem is used if you have a right triangle. Now, it's used to help you find a missing side. So sometimes the hypotenuse is missing, sometimes one of the legs is missing, but we're just going to make up a problem here. Let's do something like this. Okay, so if this is given to us and we're asked to find this side over here, we could set up a squared plus b squared equals c squared, right? And which of these is the a, b, and the c? Well, the most important thing is that the hypotenuse, which is across from the 90, that's always your c. So I'm going to call the 3 my a, the 6 is going to be my b, and I'm looking for c squared. So I'm just going to do a little bit of math here. 3 times 3 is 9, 6 times 6 is 36, and that equals c squared. Then I'm going to add these together. 45 equals c squared. Okay, so from here, most of you guys are used to picking up a calculator, and in the calculator you type in the square root of 45 because we are trying to get the c by itself. So you have to take a square root in order to get rid of that. So what you're not used to, though, is what I'm about to show you. If you type this in, you're going to get something like, I don't know, 6.8 or 6.9, something like that. We're not going to type it in, guys. We're going to leave our answer in simplified radical form. So what this means is it goes back to the old school, and the idea is, can you break this down? So I need to look for a number that has a square root. So what are my numbers that have a square root? Well, 4, 9, 16, 25, so on and so forth. You want one of these numbers to go into 45. So which of them does? Well, I think 9 does, right? Because 45 is really 9 times 5. So once you break that down, now you can talk yourself through it. What is the square root of 9? Well, the square root of 9 is 3. What is the square root of 5? I don't know, so I just write it back underneath. And this is going to be the final answer that we want to put right here. And that's all there is to it. So without a calculator, we're breaking it down just like we did on the old school. Let's do one more example. And on our next example, we'll make it a little more interesting. Let me give you, let's do this as the square root of 15 maybe, and then we're going to need sides. So let me call this one a 2, and then I'll call this one the question mark. Okay, so now you still need to know which one is a, b, and c. So this will be my c, and then I'm going to go ahead and do a and b. We'll start by plugging in to a squared plus b squared equals c squared. So 2 squared plus b squared equals, okay, c is weird, right? It's the square root of 15, and then I'm going to square it. Now, some of you may remember from the past, if you have a square root and a squared together, they just cancel each other out. And so what ends up happening is this turns into like a normal 15 over here. On this side, 2 squared is 4. Plus b squared. Okay, so from here, what do? Well, we're trying to solve for b. So I'm going to go ahead and subtract 4 from both sides, just to isolate this. And what would that be? 11. And now, to get the b by itself, we're going to take the square root of both sides. And we're not going to use the calculator, okay? Now, do any of these numbers go into it that we've written down? 4, 9, 16, 25. And they have to go in evenly, okay? Do any of them go into it? No, sir. So that is your final answer. You can come back to your picture and write it back up there. And this would be your final answer. No decimals, okay? So that's what we want to practice today. So good luck with that, and let me know if you get stuck.